big, giant, magnetic field. This is how I think of acids and bases. When dissolved in water, acids release hydrogen ions or absorb hydroxide ions, which will increase the hydrogen ion concentration, and vice versa for bases, which releases hydroxide ions and absorb hydrogen ions. The strength of an acid or a base is based upon how willing it is to give or take hydrogen or hydroxide ions, which is also known as Ka for acids and Kb for bases. Strong acids have very high Kas and are very willing to give up their hydrogen ions, such as hydrochloric acid. Because of this, they dissociate more in water. After losing its hydrogen, the chloride ion has the ability to take back its hydrogen, making it a base. However, it is not very willing to take back the hydrogen, making it a weak base. Weak acids, such as hydrofluoric acid, have very low Kas and are not as willing to give up their hydrogen ions, which means that they don't dissociate a lot in water. Also, weak acids have strong conjugate bases. Since weak acids are not willing to give up their hydrogen ions, they are very eager to take it back if they lose it. And for bases, vice versa, strong bases have a very high Kb and are willing to give up their hydroxide ions, while weak bases are not as willing to give up their hydroxide ions. And strong bases will have a weak conjugate, and weak bases will have a strong conjugate. Strong acids really like being acids, and they are willing to give up their hydrogen ions or take hydroxide ions. And once they form conjugates, they are less willing to take back the hydrogen ions or give up the hydroxide ions. The same logic can be applied to weak acids. Weak acids don't like being acids, so they don't like giving up hydrogen ions or absorbing hydroxide ions. So when they form conjugates, they want to take back the hydrogen ions or get rid of the hydroxide ions. This idea can also be extrapolated to bases. Strong bases really like being bases, so their conjugates don't really like being acids, while weak bases don't like being bases, so their conjugates really like being acids. When sodium chloride is dissolved in water, it forms sodium and chloride ions. We know that sodium ions are not willing to take hydroxide ions from water. Otherwise, sodium hydroxide would not be such a strong base. And chloride ions are not willing to accept hydrogen from water because hydrochloric acid is such a strong acid. The sodium ions and chloride ions don't take much from water, leaving the water molecules pretty much intact. The pH doesn't change much, life's all good, and you put salt in your pasta. Some salts, like sodium fluoride, when dissolved in water, do change the pH, and that is because there's a strong conjugate and a weak conjugate. Sodium ions are all chill and stuff, but the fluoride ions, it really wants hydrogen ions. It wants hydrogen ions so bad that it's willing to take it from water. After water loses its hydrogen ions, they become hydroxide ions. Some salts, such as copper chloride, can make the water more acidic, as it has a strong conjugate acid and a weak conjugate base. The copper ions really want the hydrogen ions, so it takes them from the water. Once the copper takes the hydroxide ions from water, it leaves behind hydrogen ions, making the solution more acidic.